It's okay. Welcome everyone to the first episode of the DSC monthly webinar series. Our new monthly AI and data science. Those webinar series will provide you with in-depth insight each month. We'll delve into the most current topics shaping the AI and data science landscape. I'm Yasmin Ali, Program Manager at DSC MENA. I'll be your host for tonight. Today, we're excited to dive into the topic of harnessing AI for digital transformation, insights from real-world implementations. We're thrilled today to have an AI expert with vast
Thank
experience
you.
in leading digital transformation projects in industries like education, real estate, and telecom. He's worked with the top companies like Google and Microsoft, developing innovative AI solutions used by millions of people worldwide. We're excited today to hear his insights on how AI is shaping the future of business. Please welcome Dr. Shady Ali. Hello, Doctor.
Thank you. Hello. Thank you very much. I'm very humbled by your intro. And just to simplify it to everyone as well, like I've been coding since I was 14 years old, and I have pretty much 18 years of advanced programming experience. So I've kind of like had the chance to watch the technology early rise and how it was being developed in 2004, 3, and 2. And how it has been taking these kind of a transformation, which led me eventually to become pretty much having the knowledge of like all the transformation languages and programs and technologies across so many years, which got me eventually into constructing curriculums. And so I'm used to research lab webinars. So if you got me like a little bit too technical, that's all right. But it should be in the vibe and the spirit when you are starting to get into artificial intelligence anyway. Okay, so I'm sharing my screen now, supposedly. Yeah. Okay. Please let me know, Yasmin, if you can confirm that my screen is on, because it's not giving me any.
Not yet.
Not yet? Okay.
Yes.
Let me just share that again. Okay. Should be sharing that. Cool.
Yes, we can see now.
All right. So the kind of topics that I wanted to involve around today's material is how to actually quickly understand the kind of types of artificial intelligence rather than like the implications of the programming and things like that. So I've started putting together this material that we're going to be talking about the main aspects of artificial intelligence foundation if you're looking into start working or applying artificial intelligence in your businesses, your business technologies, rather than just individually as well, but how it could be integrated in our businesses and daily life. So we will be talking about the main aspects of which is machine learning, the natural language processing, problem solving, automation, and adaptability. So it's basically how I've put together the journey of constructing artificial intelligence. It has so many technical, deeper level, but there are some fundamental stages that you undertake when you're doing AI or you're trying to create an artificial intelligence program that is individual basis, business basis, how to talk to artificial intelligence in hardware as well, not just software. So there is like a lot of main aspects that starts with the journey of that you have a machine, which it contains of like the basic fundamentals of constructive computers. Like the computers that we construct, like we don't buy stock computers. Back in the days, it started off by modifying motherboard and computer hardware when the gaming scale was so big, and they started getting into user customized kind of computers or personal computers, and they started to see that there is a lot of intention behind this generation to be able to perform technological events. So it started actually from there, constructing the hardware itself. The bigger the hardware was contained, the bigger the stage that you're in into like create more possible scenarios using the computer. So it definitely starts from the hardware to have a machine. And the machine, whenever you hear the word machine and machine learning, it is an actual physical machine. There are virtual machines and there are physical machines. The physical machines are the most powerful artificial intelligence models on hardware, computer hardware you can work with. Basically, it all starts by you're building the machine, and then how you start to work with the machine or to talk to the machine. That basically installing like operating systems or like customized operating systems, you have to think of it at the start. So basically, you teach the machine whatever the outcome that you possibly think or planning on your project or complex programming, you would start to have the machine actually help you implementing your developments. So there are three main types of machine learning, which is supervised learning, unsupervised learning, and reinforcement learning. The basic model is supervised learning. Supervised learning is something that you start have that computer. I'll graphically try to manipulate this. If you have a graph of an upload where you upload an image and then you have three options down there. You've put a picture of a boat on a lake, and then you start to describe to the machine what is in the picture. So this is like the lake. This is the shape of the boat, and this is how the boat being constructed because it understands the pixels of it. So you start to somehow talk to the machine, or this is how you teach the machine starts to learn with you, is that you teach the machine the possible outcome of that picture. So is this a picture of a boat? And you have the graphical inspection of the pixels on the computer on the screen. This is the shape of the boat. So I put 2, 3, 4, 5 images that all contains boats. And I tell the computer each and every time this shape is a boat and it exists in that photo. This shape is a boat and it exists in that photo. And then I'll start to put, all of a sudden, a picture of a car, not a boat. So then the first outcome of the machine talking back to you is going to be like a yes or no kind of thing. So basically what you do is you tell the computer that now I have a picture of the car, and instead of a picture of the car, and the computer would say if this is a boat or not. So it starts from there. If you say this is not a boat, so the boat does not exist in that picture because it understands the graphical effect of it on the pixels. So it starts saying that this is a car. So, and then you open like an algorithm on the machine and you start from a simple, very, very simple yes or no functions into expanding this module with your computer or with your machine. And then you take it on and on and on and on. Then the GPUs inside the computer would understand that this is something like an eye. You start having artificial intelligence that sees things and recognizes things. So this is the module. It learns from you. This is the supervised learning model. The unsupervised learning model, which a lot of people tackle, and a lot of people mix between unsupervised learning and NLP or natural language programming. And it's like they're really thinking that this is the mix. And we all watch it in movies and we all watch it everywhere, that there is always the prediction that when you leave the AI alone and it starts to learn from itself, it will turn dark and evil and it will control the humans. And it's like, it's never like that. And it will never be happening like that. Unsupervised learning is the ability that the machine is constructing results on its own that so instead of like, to use the same example to make it easier, if I don't put a picture of a boat and then I tell the computer, can you output a picture of a boat? And when it starts to construct these pixels together, it will have 2, 3, 4, 5 times of failure. It will give you a ship, a huge cruiser, it will give you a square. Then you will, each and every time the computer is saying, this is a picture of a boat, you'd say, no, 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 no. Then it goes back and it tries to draw it again, and draw it again, and draw it again. And each and every time you're saying no, it understands what are the differences between what it did and the previous one and try to get into the shape that it has in the GPU itself. Then eventually it gives you a boat. So I did not supervise this learning. I let the machine try to construct something and talk back with me, and all what I was doing as itself is yes or no kind of approach. So basically I've let the computer try to learn on its own. So this is like unsupervised learning. Unsupervised learning is so subjective and it's so object oriented where you can never be scared of. This is what I'm trying to say. You can never be, because it can be so objective that it learns certain things or develop a very, very sub functions. So it cannot contain all of them and have like the supercomputer unless you have worked on too many machines and each and every machine is constructed to do something and then you created larger machines. So this is the unsupervised learning. Reinforcement learning is basically you have the computer when it's doing like a mathematical equation, 1 + 1 is equal to, when it each and every time like I try to manipulate the answer, I'll give it the answer somehow. And the beginning to understand the logic of how to run the algorithm. So this is basically, if I didn't tell the computer, draw me a picture of a boat, I started telling the computer like each and every time you're going to perfect the computer, the image that is generated by the computer. Whenever you try to enhance it and make it like colorful, add colors to it, to use the data that is stored inside the machine to actually start developing itself on a model that it will make the things better. And it would start to have like colors on the boat, maybe that's like, and then of course, if you're teaching this machine, you will be instructing more and more and more boat photos so you can understand like how the boats are being sailed. It's like there's a sky, there's a sea, there's the town, maybe sometimes there's a town, sometimes there's no town. So this is all the training that is happening behind. You can then construct a machine to say like, okay, you try out to construct a virtual reality of your own and give me a picture. And whenever the picture is more colorful and it's more good, the more that I'm going to insert more pictures. So it's kind of like talking with this like bribing machine. So it's like, I'm going to give you more and you start to give me more. So basically, this is the model. Now, how this is being done, it's using Python, R algorithms. There's like so many languages that you can develop a machine on. There's so many platforms. I'm going to talk about them at the end of the demonstration anyway. But there is like too many technical environment that you're going to get into, and I'll show you how to get into and how to get like a possible specific field in it. So basically, this is the machine learning in a very, very simple tasks and a very simple. Inside the machine learning, I'll show you as well how the companies now, they are building the machines to have the ability to learn on its own from their own systems and their own workforce systems, time booking, agile methods, Scrum. There's so many things that can now, with this model, imagine this model every time you think about a project in it. If it has an ML in it, if it has a machine learning in it, this is now you understand. It's like sometimes now the machine learning can understand the time booking in companies, the Scrum Excel sheets, the tickets in technology, for example. And our technologies now, we're using so many artificial intelligence we never believed. Like somehow now we've made it a lot easier to enter AI without having a very advanced coding background or programming background. There's like so many rules that came out of artificial intelligence now that is not directly specific to that you are going to have to be a super Python engineer or you have to be like a JavaScript freak. You don't have to worry about that anymore because artificial intelligence is enabling a lot of fields that you can get into without having that kind of content. Sorry. All right, sorry. This is supposedly, so like, I'm just gonna, it goes so quickly. Yeah, all right. The AI models, like the models of machines, is either that there's a machine learning, a machine that is learning from itself, from algorithm, from mathematical operating system, and so on. So this is the usual machine that AI is being trained on. If you will get into like deep learning modules, these are the kind of a scary one, and this is the kind of like a very, very advanced kind of artificial intelligence. And this artificial intelligence is actually capable of like drawing patterns for itself and it's learning. So whenever it's learning something, it's documenting it and understanding it and will never forget it, of course, because it's documented in the computer. You can understand like what was all the possible method in this outcome or this scenario or in solving this equation or solving this problem or understanding what's written on. So this is CNNs, we call this like convolutional neural networks, which it's not a neural network. It's not like a human. It's like yeah. Neural networks is basically certain algorithms with patterns on programs, and you have packets of these programs. These packets are on its own, each and every one on its own is like different AI models. So imagine have a team of 5 people, and the 5 people, each and every one is very, very super at what he does. One is a coding freak, one is like sales freak, one is a marketing freak, and so on. So like these are machines that get together and take the decision together. And you're all learning from one another. So you move the machine learning methodologies, normal methodologies, to a higher modules where you're developing a space where all the machines can learn from. So from each other, sorry. So each and every shared experience that has been trained in labs or in companies or by programmers, all the machines that have been trained for so long, they can finally share the information together. And when they share the information together, they get into understanding higher algorithms that requires further and further advanced programming. So these packets are, some of them are binary packets as well. It's all you have to manage the data that is coming from too many machines all at once and make it understanding a specific task to be done out of all these machines all together, compiled together. So what you do is like you build a higher kind of equations and rules to this machine to be able to filter out all the possible learning into getting into a possible outcome that understands all of it. In this, the programming level reaches a level where you're teaching somehow the artificial intelligence to be humanitarian somehow, like not racist, not to use like the offensive languages offensively because it learns from that, and there's like it is in database, so you can finally find yourself like have the NLP program or natural language program that compiles the offensive words together because people use it a lot, for example. So you kind of have these rules and have these equations to filter out what is coming from machines and make it as adaptive and decent enough for a user to use. And when you do that, there's a lot of institutions and a lot of companies that work in that area only. So in this field, there are institutions for AI, but this is how I was saying like AI jobs now, or careers now, it doesn't really have to be programming, because there are institutions that make sure that these binary packets or the packets that are coming in is doesn't have anything offensive, doesn't have anything for developing a chatbot online or developing a program that programs a program. So basically, these are institutions and companies all over the world now. They are working specifically into putting together some the neural network of the computer, not to go extreme. So that's the deeper level of machine learning. So ensemble is basically you're having the hardware mixed together. So we have the models all sat in one place. Now people like you can use this as a virtual machine. Like Shady and Caro, I developed a machine, and this machine learns how to program or how to code. And there's another guy in Australia that developed a game that's something in an NPC player character that is able to visualize itself. You can take from my machine, and can take from his machine, and can like have a model in between, an AI model in between, learning from him and learning from me. So basically that happens, but on a larger scale. So lots of companies do that, lots of companies and institution research labs that are always in constant development into how to stack this intelligence together and somehow being able to get something productive out of it, we can say, and avoid any kind of repercussions of like the data that's being understood. So algorithms. I was speaking recently now about algorithms, and the algorithms is like the same as the machine, that when you let the machine study from itself or learn it from itself, this is unsupervised learning algorithms. And when you put the algorithm or put a stack or rules on the machine to kind of like conduct all the actions that you want and not to be distracted by things. So this is a supervised learning algorithm. So The algorithm works with somehow to go back to like the picture. If I'm putting a picture for the boat in the lake to the computer, and then I told the computer there's like many possible scenarios. This lake to be colored for this and this and this and that, and start to talk to the program about the possible scenarios that can come out of this photo. And then without having to upload many photos, like this is the learning algorithm will be understanding like from the photos and start to be visual effects. But now I'm just like inserting one or two, three photos of the lake, and I'm saying like this lake could be wavy, and it's wavy, the water. So I stopped talking on a text basis, like Bash programs and a very, very kind of old program extensions. So basically, this is how you have the machine learn from itself and not to learn from itself. Some moments where it's like putting together a virtual machine or a machine that's working with you have to put a supervised learning algorithm. And if you've left it unsupervised, the patterns are inside documenting each and every time the machine is attempting to solve a solution or something and see if this outcome is the possible productive outcome or not. And reinforcement as the bribing. This is a scenario where like whenever I love reinforcement because it always like gives you the actual intelligence that you're dealing with a machine that you're developing an AI, which whenever like the computer gives me a good photo of a boat in the lake, I would just upload more and more data and just like make it productive and somehow have it interacting with like larger amounts of data set. And by the way, there's like algorithms on so many advanced level. They are the algorithms that contains like somehow the social media for keeping the social media not to post anything that is offensive, that is not appropriate, and things like that. And also companies, lots of companies, data companies, they worked with all the social media around the globe to construct these kind of algorithms inside the tech companies so they can focus on social media. And there are some other companies that is focused on building the algorithms and scripts and algorithms to be able to contain social media, for example, social media platforms like Meta, for example. Meta defines as now they have it internally, but they used to like to have like companies that works on the kind of a regressions of filtering out the data and making sure that everything is posted online or uploaded online is intact and it's not offensive and such on that. So these are super powerful algorithms that requires like years and years of developing. And that's like we could say right before the ultimate level of algorithms. Computing power. I was talking before, like to go back to a machine, when you're constructing a machine or buying a machine, like I use this term because actually this term is what happened in when games started to become like more and more advanced. All the computer users like who've been into games, they've been into constructing other kind of PCs and powers inside their mother. So if I have like, for example, I have a machine here that is cut open and everything is on a rack. It's on another board. It's not containing CPU. So customizing your CPUs is an efficient way. Of course, there's like the user kind of AI powered. Each and every chipset now is being produced as AI powered that has the capability to understand. But if you are getting into artificial intelligence and you are getting more deep in artificial intelligence, you would start by having your own computer or your own machine and put it together and like somehow understand on the all the security measures that you're going to put fail safes and something like that. You can look that up online. You can look up online on YouTube like how to construct an AI machine or a CPU or something like that. You would find a lot of like this kind of customizations that's going on the machine level. So a graphic processing unit is the GPUs. This is basically NVIDIA. NVIDIA is one of the companies that witnessed the gaming platforms becoming too big, and they started to understand that, okay, there were going to be more required graphic cards, more required graphic cards are more required because the computer, as long as you want the computer to give you like a higher resolution, to give you a higher frequency, so you have like to power the computer with the hardware ability to be able to do that. This is why I always go back in artificial intelligence. You go back to the machine a little bit or an inch of time that it starts with the hardware. So companies like NVIDIA, they develop the driver that you can put in the motherboard. That this driver can do any ideal things on a manipulated screen, or a screen that has games, has videos, has anything really. So the graphic card that understands the depth of the programming being done in the picture and can actually output that. So basically, you can look up the computer history online, and you would see like how the computers were basically the pixels were too big, and so now it's got shrinker and shrinker, and now you have like a 3D screens that actually can do hologramic pictures, what you can see. And the way that NVIDIA is so much of a success is because they were developing the kind of all the artificial intelligence powered devices and hardware that other technology companies is using. So basically, NVIDIA used to develop the GeForce drivers with customized for Microsoft, for example. It's customized for their program because they put it on a larger machine, a huge computer that has so many parts from so many providers to be able to give out artificial intelligence graphical events. So basically, this is the GPUs, which is like the more powerful you have RAM in the computer, and you have like dedicated storage in GPUs, the more you powerful into training the AI model and visualizing things, or things that are like videos or images or drawings or something. So tensor processing units it's basically for all the tasks that are being done in training references that are more user adaptive, or more less and more user friendly, we can say. Like when you put these processing units inside your computer, you kind of like have you kind of have the ability to have the AI do very, very specific tasks. And this is actually where it started in IoT, or started in smart home solutions. So basically, I'm going to use this example. Like in a home, like I've looked into like customizing a computer for the house, for to do everything around the house. So basically, it's Raspberry Pi environments, Python environments, software that's like the CDMA in between. There's like so many hardware in between, and this hardware is manipulated somehow into talking together. So if you put a chipset on the light, and you put a chipset on like on a sensor maybe. So these basic things people like kind of miss, but there is like so much automatic and supervised learning behind it on the computer level. So you have the sensor, when the environment in the computer of the sensor senses that there is someone passing by, it sends for a computer, it sends to a computer or a machine that says someone is passing on a light, so it gives another order in the computer to turn on the light. It's basic as this, but it started to get too big into constructing like security systems, heat systems, like innovation solutions and stuff like that. But basically, security nowadays, you have camera. Google is very, very good at that as well. And these kind of like user-oriented kind of products, they have a camera that you heat map a certain area in the camera. That if your dog is walking by the backyard and you have like a space that I would Broadway, if the camera senses that the pixels changes in that certain image and certain picture, it will somehow give you a notification. Programmers, they found a way to take that and build a further outcomes on other machines, on other computers. So when you see the dog is going out in the backyard, for example, you can turn on something else out in the backyard, like a laser camera or something like that, something flashy or a flashlight, to flashlight for the dog so you can come back. So you started manipulating the environment into having more and more larger scale of orders and commands that you can get out of the computer. So it's basically any product that is high performing in a matter of censorship that has an AI in it, you can take larger and larger amounts on that. And there is the open source, open documentation, and every in each tech company is always up to give you all the possible coding and programming and everything that you would be constructing something like that. So these are basically what the AI Labs does. So, okay. All right, stop. Okay. Deep learning, one of the things that we were talking about deep learning is the basically now, and how the AI is getting into our lives right now is developing the programs that are able to learn from itself even more. So you've got ChatGPT, for example, is a model that right now it starts to like have certain tunes and intelligence behind how it's replying to your questions. Well, and the very first models originally like that, it was just very programmatic. But now there's like an ability to understand the emotions out of what you're saying as like somehow learning into the modules that are becoming more of like output for the machine, that that machine can output as much as it inputs, and it inputs a lot, and if you get all of our experiences and all of our life. But now she start to use that. So when you're using an AI with such a background with purposes data or open AI's data, you will be able now to by now construct somehow an algorithm and the way they're replying to the messages that you're sending to ChatGPT, being able to construct a voice and to construct voices now, like there are in the labs, the kind of an ability that the artificial intelligence would match your tone of voice. So when it talks to you, it can understand like how your input, like in the sound frequencies, when you talk to the Alexa or you're talking to an AI to device, when you talk to it, it will start to put this voice and this tone and the tune melody and mathematical frequencies of the tune. It would understand that the low tunes means the person is upset, is sad, is whispering. So many levels on a computer that you can measure and have frequencies on that you can put together into a possible certain reply that contains the same data sets. So we have different data sets now, like data set for the learning when someone is speaking low or down or crying or happy or excited, or it's like you have different data sets and then you put that on a model that has a super algorithm to be able to make an output. The data. There are the two types of like structured and unstructured data as here in the presentation. So the data now, when you're storing to the computer, back to the very basic model, when I was giving the computer a picture of the boat in the lake and saying this is the boat and this is the lake, now I give it a structured data. Now it understands this type of like this highlight of pixels equals a boat. So I give it a data set, a database, sorry, that is so much organized that he can understand each and every outcome of the things that are being input or being so this is a structured data. It's kind of like a supervised machine learning. So when you use it in supervised machine learning, when you use machine learning modules on a structured data level, you're able to get more automations out of anything that you're programming. So basically, if you have the model that contains just a simple yes or no kind of an AI program, or the programs that are somehow being inserted in the chatbots nowadays, that you have a more structured data set to understand. Like now, if the chatbot on a website, it is programmed to each and every. It hasn't certain websites now is integrating this, but it doesn't have an NLP yet. So it gives a specific. Are you open today? No, I'm not open today because it understands from a database that this program is the business, or this is a business program that is switched off from 9 a.m. to 10 p.m., for example. So the computer has the time and reads the time and says, no, leave a message for tomorrow. The more advanced unstructured data, and unstructured data is always more advanced because now it has less interaction from the scientist or from the human being. So basically, the data when it's not organized, but you have you can see like he says predefined manner. The predefined manner is the algorithm. So you have a decent algorithm. It's like you don't go extreme. You became decent and super productive in your outputs and stuff like that. And you put that on an algorithm, and then somehow you're able to get unstructured data that takes an input of a lot of data and structures it together before it makes an output. But you have a super algorithm that manages this. Data processing is often the when you take the data from the machine. There's so many pictures that I have uploaded to the computer. There's so many inputs. There's so many Excel sheets. There's so many notepads or text that I insert into this computer. The storage of the computer has everything recorded. So if I'm talking like if this session is not recorded, for example, we're gonna go along and along and along, and we never recorded. So we were not going to be specifically understanding and remembering we were saying this exact words. The computer doesn't. You want to understand that this at this very moment this happened. So this data that the computer has, and it starts to process it and organize it and put it in data sets and put it in models inside the databases, that has libraries and blocks and knows exactly when are these libraries are open or being exposed to the model on the AI model to be able to make a certain output or something, or to talk to someone on the chat board. So there is the data set. The data processing mainly, the advanced level of data processing mainly nowadays is when you have a predictive GIS, for example. There's a lot of companies now depend on the predictive analysis of artificial intelligence in finance and stock markets and data processing governmental solutions. There's like a lot of implications now that we're facing as like in the world. And we started leaning towards AI to actually help us solve the equations. There is something, a project was data forensics, it's called. Data forensics was a project or as a research lab that has, for example, now when you walk into a courtroom now, I'll give you an example. You walk into a courtroom and start saying, this guy stole from me. And I have a video that says that this guy stole from me from my store or from my house. And this easily can be manipulated now by using computer. So basically, how the legal system now is being adapting itself to the kind of evidences that is being provided to be able to apply that this is a real thing, or if it's not a real thing, or fake, or it's not fake. They rely on the processing scripts somehow, or certain scientists around the world. They reach out to them with specific data sets that says like, here are all the evidences that we collected today in court. If we can identify if this is fake or not fake, if there's like any computer used inside this. Once you give it to your machine, the machine will understand if there is a single computer used inside that, you will understand this is a single computer used around that. So you bounce back to the courtroom saying that this data is fake, so the evidence is dismissed, and you get charged as well. So basically, this is how, if you're having the ear for AI, or you want to get into AI, there is the engineering and there is the data. The engineering that you're getting inside the machine learning, programming, software, you're doing a lot of like AI input related, and there is like the engineering where you have data and you have data scientists and you have data science now as one of the main structures of constructing any organization around the world. So you'll have some sort of organized data science platform where you can get much more done in your businesses out of the society. I'll show you at the end how we're going to do that as well. So types of AI, there's narrow AI, general AI, super AI. The narrow AI is basically the supervised machines or the supervised models. General AI is the models that doesn't use the structured data or has an algorithm to control the output, but it doesn't have like rules of input. It learns from certain data sets or databases. So they have a general AI where the machine is unsupervised. Super AI is something that is somehow being evolved now from artificial intelligence, which basically goes into two paths. There's an extended intelligence and there's organoid intelligence. Extended intelligence is basically how much now, for example, the AI is able to produce video or to produce short movie. This became on a stream. So this is something somehow will be either has a place in the world or doesn't have a place in the world because it cannot take over the world. So in Hollywood now, they are adopting the idea of generating is to work with the AI is generating digital likeness images that will be able to construct a movie, an entire movie. They're working on that parallel to the ability that the AI can do it on its own. So there is constructive feedback loop that is happening on such marginal machines and such marginal like expanded learning curve that is making the AI so super that it can now start to develop any kind of like constructive image, or doing the simplest practices. Like yesterday, there was a lab that was testing the idea of if the computer will it have a visual performance that is higher than a human being. Just visual. Doesn't analyze anything. No super cameras are being used. Nothing. It's just a simple camera, 16 megabyte camera, and it's testing whether it's going to have a better visibility or not. And a week ago, it turns out the results that came that yes, at some point, the computer was able to develop its own camera and image processing of the room that it can see on certain changes, and it can even see in the dark, and it can see a lot of things out of a simple eye program inside the camera. This is somehow the achievements that artificial intelligence we don't want is to go, but yet it is going and it's available. So it's kind of like somehow holding it together, not to construct it. This is the extended intelligence. It's not going to be out till I think 2026. Maybe there will be some extended intelligence in place, which is a very powerful AI model turned in extended. It has so many data and it has so many output scenarios that it is able to become creative just by constructing some images together. And how the people would ask how the AI is getting creative is because of the amount of data that is being constructed. So imagine artificial intelligence now is already inside a computer recording each and every movie that is being displayed on this computer. So imagine the kind of a storage that will never forget a thing. It will never. And the amount of the storages with the data sets, the AI now kind of watched more movies than all of us together. So it has the super extended intelligence of if you ask it about anything, it sees everything in the movies and it can understand all the tone of voice, all the action movies, all the categorizations and the scenes in between. The eventuality of it will be that it has a super archive that when it starts to have certain orders of constructing an action, comedy, horror movie, it will be able to put it all together. Why? Because it understands the entire history now of movies. So it's always referred to back to a human input, but the human input, it has increased so much that the computers now are able to create and produce things like how do you produce it? How do you do that? We got Shady, we got like millions of Shady, or we got like 250 people in a room and they all have an idea of the movie, and you ask just one person to collect it all and get it all on one single movie. And you can do that in seconds. And how it's becoming in seconds is how powerful the hardware is and how fast it can find information out of the data sets and the models that are being super organized. That is like data structured data that is super organized for the AI to get the information from. So the faster it does it, the better the data set are, or the data that the AI depends on are. And on the other hand, if it's somehow, yes, I am planning, sorry. So when you have like the super AI in place, it will have like a super structured data that can be like a corpus of data, like GPT or something. You'll have a super AI that can organize so many words and so many data sets and so many understandings of so many essays and articles, and it will be able to give you a response as fast as it does. Now, the other part of super AI is organoid intelligence, as I see. In my own opinion, is organoid intelligence. Organoid intelligence is like how you start using biology with technology with AI. So you come up with organoid intelligence. So, but it's the evolution when the AI touched so many fields and started touching the medical field, and understood from the medical field as well, that now there are possible like biotechnology projects that are being studied and done for disability or for flood programs or like underage patients. There's so many wearables now. There's so many wearables that are being done in the health system is powered by artificial intelligence, from the helping people to see better, to hear better, to breathe better. There's a lot of AI programs that are seen in certain chips that are Raspberry that works on the platform. So these like a Neuralink platform. Neuralink platform hosts a lot of algorithms for a lot of projects that are being used for medical use. So, but at that point, The organized intelligence, this is the bit of a dark side of technology, we could say. But it's actually having a brain cell that it can be integrated with the motherboard somehow, and this brain cell will be growing and everything, and it will like train the same nervous system as a neural link kind of a program. So you map out all the thoughts that are being happening on that brain cell. So the brain cell is moving out the information, these neural links. So when it moves the neural links, you will be able to map it on a computer. And when you're able to map it on a computer, you'll be able to train it. And you'll be able to train it, you're able to grow actually. This in biological sense, because why it's being tested or why it's being approved to be tested even, it's because it will be energy efficient, extremely energy efficient somehow. That if everything is off, it can still work because it has biotechnology. It doesn't just like rely on technology, electricity, or anything like that. It is biological somehow. So this is like the organized intelligence. Organized intelligence for me, this is like the scariest part of AI now. And there's like so much development is happening into it that I believe like it should be remaining and staying in the health system, but it should definitely be something of an interest for someone who wants to get into artificial intelligence or get into the field without like having to go backward and get everything and get all the types of AI fields. And he wants like to join a super fresh projects that are being conducted with extended kind of technologies from artificial intelligence as well. Ladies and gentlemen, 2024 is available. So yeah, sorry again. Applications of AI. So now we have given an example of the smart home devices. And now you would able to like I wanted to put this slide on because I wanted to like now we understand machine learning, you understand algorithm. I will like leave the programming part for like maybe another like episode or something, but there's like so much programming behind it. But now I just wanted to widen your vision around the technology field in AI right now. So the smart home devices is not just a manufacturing business. Any of these businesses is not just manufacturing businesses of computers anymore. It's manufacturing and software. So I'm 100% now relying on the software capabilities to be able to build the appropriate hardware for it. And this is one of the transformations we have ever witnessed. So by saying we, I'm saying like all the people are like on this 2024 right now. So because basically, if you go back in time, this is the area or the era that we're living in right now. This is the only era that I've seen the classics when people used to call each other on the homeland lines. And then it started to integrate into now, like we have even holographic devices now are being tested to be sold in the UK, that you have a teleported kind of a video program individually as a user. So basically, these later on becoming more smarter and more smarter by this era, it will be the witness of the history of the transformation. So this is actually the era of transformation. So you're getting into a small builds of AI into larger builds of AI, and the AI is helping us a lot to be able to more productive outside of like the usual terminologies that someone invented something. So basically, if someone invented something, meaning that if the hardware industries are producing, back in the days, they were producing the abilities of constructing a mobile and a chipset and everything in that. And they will keep doing that because at the end, it's still a mobile phone, a tablet, a computer, a device, or something that you can put in and on it. So basically, you have the devices. Now the artificial intelligence is giving us ideas on how to develop the hardware and the engineering. Because imagine someone developed a computer, someone engineered a computer or invented the computer, someone invented the mobile phone, someone invented tablets, someone invented the TV, and they all put together because now this is exactly what the machine and unsupervised learning is happening. Because now it understands that there's all these manufacturers that have done them in place because it's on a computer and it uses the computer to help them. Now these data sets or machines started to learn from each other from like an AI model in between. It will understand now that, oh, if I mix the screen of the mobile device with somehow to be on the same area in the TV to be a touch screen on the TV, you will be able to do that. by conducting all these factories together, or hardware together, and start to construct this kind of hardware. So this basically gave us the abilities to construct even and to innovate more in engineering and conducting of devices that will be able to help and support the AI being involved in our daily life. Now, there are like laser beams. You're going to see the laser beam technology next year. There's a user technology. User technology means something that we'll be able to purchase normally as a user. You will be able to see how you can construct the shapes anymore, and you can construct the shape and put it on a holographic, the kind of a laser wave video that only gets its power from a nanotechnology that is being produced all the time. So you can basically have this hologram working forever without any kind of an implication of a battery or solar system or anything. So why? Because we're mixing technologies together to be able to make the hardware, or we got the technology experience of artificial intelligence and putting engineering together into construction sort of thing. So smart home devices, of course, this is like basically the engineering part, maybe. The personal assistant is like when you say now that we have so many kind of assistants in place. You have Alexa, you have Siri, you have Google Assistant, you've got Microsoft Assistant, you've got Copilot, you have a lot of assistance software now that are being developed. And by able to do that, let me tell you an example of like how basic you can start your AI model is. I started a Python program that would just like giving me a form when there's like someone that is age is equal than or smarter or larger, sorry, than 30, print or something in Python, which is going to print rejected. And then it started developing from there, that it developed a mini form on a website. And then from this mini form, I started building upon it that a huge system now that was 7 years of work. But last year, that was able to be embedded inside the healthcare system and the insurance companies that will be able to take the decision in your application without even to have passed to a human decision, because it's with you from the construction, from the application, from the beginning. It sense how old you are down to your extreme medical health, your everything, the doctor sees everything you've put on, and then eventually you will have. I'm sorry, but let me just turn my lights on because I think it's getting dark. Just 1 second. Yeah, all right. I think that's better now. So basically, so now you have that kind of and the assistance on any level of many levels that can take all the decisions as well for you. So you program something, yeah, it's like the Python program is now able to, like, by the time you finish the patent registration or your health registration, you will get the final implications of like actually having to take decisions right away. That saved like I will have years and years that it could have been in work that is being done by human interactions into forms or applications that and if you look at the studies, there is like a study from Nielsen that came out that says like the kind of work that have been involved in forms specifically, it reduced 300 hour per week. So like more than what the week has. So it's like more than multiple people taking a decision on one person all at the same time. It would be faster than all of them. So basically what happens is I know you might be thinking now that, okay, so that's for processors at the insurance company, they wouldn't be able to work on it. They will be able to work anymore. And they will be able to work parallel to artificial intelligence. It's not going to be completely in like what we're doing now is like whenever there is an AI that is taking out a department in a company or taking out an actual like a vital role as a human role in a company or a position or something, before we start like creating these models, we make sure that the people in that field or in that position are able to construct platforms or to construct a relationship with technology to be able to work in parallel with these kind of assistance understandings or the algorithm. At the end, when you're developing the algorithm, you need a human to develop the algorithm. And judging on where the world is right now, algorithm developers, they are so few to the amount of AI that is being in place. So you can find a scripted job that you can so much evolve with you just because you're scripting algorithms. And by scripting algorithms, you have so many Python codes in place that all has like packets of understanding rules, and these rules you just put it together in a data set and build a model on top of it. So, and when you build a model on top of it, you take the intelligence of the model with the rules of the model and you send it as a script. And then you take on and you can become like an algorithm scripter or a super algorithm scripter. It's a work that's like being specific with Python, Raspberry Pis, and R. You will be able to construct. There is a huge field that's being opening just for that. Same as the data, but as well, being a scripted just for algorithm, putting some intelligence to work at research institutions or technology companies. Online customer support, I think we all know now that the online customer support is like already been integrated with artificial intelligence for the past 7 years. But what's coming up is the NLP or the natural language programming, which is maybe I have missed saying what it is during the unsupervised learning. Unsupervised learning and machine has something called natural language programming. Natural language programming is when you put so many text in an article to the machine. If you're talking about a basic model, you will have a machine that you put a lot of text, apple, 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 and then you put in the words, and it's like this is the word as it's an apple word. This is a word together. It always come together. Always come APPLE. It always comes in this shape and this character. And you start building on like articles and more text and more text and more text. When you ask the computer to put together data sets for all the articles that I've done, or all the words that I have been using in my entire training to the machine, if we put all the text and you put the dictionary on top of it, you can put like more input on top of it. Like the dictionary is like the grammar on each and everything, the meaning of each and everything, the definition, and so on. Whenever I asked the computer this time, what does apple mean? He would say that the apple, he understands the word apple now. What does it mean? The question mark, what does, or the what question means, it would put an order or a command on the machine to find the data set. So that's understanding that it has to respond. So then it goes to the data set, seeing that the apple, well, yeah, apple has been contained along with this and this and that, and has a definition. So basically, you rely back as like apple is a fruit that has this and this and this and that. If you have a GPU on the computer and you started like teaching the computer on like how the apple is shaped in the graphics or inside of like the pixels, and you came back to the question of what the apple is, or can you send me a picture? You can put that or not put that, and can do automatically is give you a picture of an apple. And this is an example of an apple. Evolving into this, so many an understanding of language to be words and sentences to be constructed together when it goes to an output, when it's replying to you. And hence the GPT models started to raise us like this is the idea of a GPT model. And then when it's starting to evolve, like it's all the same model, whether it's you get voice command or you're going to use text command, or you're going to use video command, is always the same. With the computer, will relate to the text at the end. So you take the text, construct it, and then give you back the output. So a lot of the scenarios now in customer support, what's going to happen is now the customers or the companies, let's imagine a food company or food delivery company, for example. Now they understand there's so much concerns that are coming out of this kind of boxes inside the chatbot. This is when people complain about something. If you say, I don't ship, they would say like lots of things. That means it's set. And puts it in a data set, put an NLP on top of it, and then it will be able to solve the customer solution outside of the things that the commands and the models and the AI that is integrated between getting the input from the user and work inside the systems or the organization systems inside the company itself. Whether the company has a CRM, it will understand from the CRM, this is the budgeting for refund, for example. This budgeting should be going with this data set, the extreme kind of measure of scenarios. And you have a budget for it. It's all in the system. They would be able to, okay, you've messed up. That's Uber as well, like uses this. So if there's an incident or a refund that it says a refund, and then it can be seen that it has a budget and it's on block one, it would take the decision right away. And it will even take the decision to transfer it to your wallet because it's also in the finance system or the ERP. Your customer call data will be shared with a specific features inside the components of these systems. So it takes from these systems, it starts to take actions. So CRMs has evolved, ERP has evolved, because these platforms, they do exist as the part of any company around the globe. So it's basically not a specific, any company around the globe that uses computer now can use artificial intelligence into putting a model, putting this VM machines, like putting this algorithm into their systems and be able to build a response-based blog. So recommendation system is basically like I'm going to use the predictive AI models. There is a machine that learns that, for example, these are like the very, very specifics of like stocks or stock algorithm, for example, now being read by AI. You see different kind of stream of commands. Like, for example, if I gave money to X and X should be paying me back X times 2 in each 10 days on time, then increase the limit in each and every time there is a payback to this data set. What happens is each and every time the customer, this banks, for example, the customer is behind on payment, you record that as 1. Whenever he goes back again on the second month, or this time of 10 days, the computer would read if the payment was not made, it would give him 1 times 3, so it's 3 net. And if he came on this base time in 5 days, he made the transaction, you bring it to 0. He didn't make the transaction, it became the 3, that becomes 9, and becomes 20 at some point. Now, for the other opposite example, if the customer is paying on time, just in time, you give him a score of -1. -1 being a good thing, a -1. And if he's paying before his deadline, you give him -3. And if he's like, and so on. So this is a point scale system. The point scale system is a system where you design a volume of like a transaction or a command or something happened on a computer, like a payment on the bank, like this is the evolvement, by the way, of like workforce and Pipedrive and Salesforce CRMs and systems as well, because it's time-based. Whenever this action is being performed on the computer, you give the point scale system scoring. So at some point on that scoring, you get an algorithm set up that says if this customer is a good payer or not a good payer, the system will understand because it has a point scale system. So when it has a point scale system, it will give you a recommendation. Oh, Shady is a good payer. X is not a good payer, for example, or is not paying back in time, or is delayed. His scoring system is 26. So you will be able to take a decision to say, okay, I'm going to go with a good payer. Now, artificial intelligence can make that decision already. Now it would understand that the more your point scale system on the computer and transaction is bad, the more services on the other hand can block them. You will not be able to get a loan. You'll not be able to make another purchases on credit or something like that. So there's some other computer, they all running together towards the same hyper terminals that understand that if the point scale system is wrong, they're give them that output and measure on this the kind of an automation that you have to put in place and the kind of like algorithm to have in place to be able to make a predictive analysis, not just in short terms, but on the longer terms. Longer terms requires more volumes of data. So since predictive GIS algorithms and modules has been there from 2016. 2016 to now, this is enough time to be able to predict all the stock market changes, all the finances changes, all the banks related systems and stuff like this, like from a user perspective and a corporate perspective. So basically building recommendation systems is you just build a model that talks to data sets, different data sets in your organization, your in systems, and be able to pull out specific information when is required using a GPT model in between. In e-commerce, I think by now you understand that there are some algorithms that develop Python programs, that everything now is done basically over the computer as well, that the AI now can. This is AI versus automation, because this is always an interesting topic. But automation is supervised machine learning. And when you have a machine that is doing specific tasks or specific commands based on inputs, or rather, like if these inputs are like human or non-human, then it takes the action. Now, imagine if the same point scale system is inserted in an e-commerce. You have a reward system. The customer purchases more, he pays on time, he doesn't have like delayed payments on any of that, give him more points. So this is a reward system that you can take and build upon. For Booking.com, for example, was looking into like completely an AI solution now that measures all the Genius Level 7 to have them on like boats and trips, and that everything that will be booked inside the system internally, that you wouldn't have to take any single decision on it. So the more you book with them, the more you're gonna get automatically, without even like doing the finance and paying the vendor, paying the tenant or the hotel. Everything will be done automatically as well. So basically, forming an e-commerce platform around the rewarding system. This is the base application of AI and e-commerce. Plus, that you can use it with shipping, you can use it with the internal CRMs. Any company now, like I think what I'm trying to say, any company that has systems, regular systems, normal systems, can build up an AI upon. So healthcare is the same. Healthcare biotechnology now have become to a point where it understands nanocells, and with the computer capacity of like to read the telescopic imagery as well, not just sorry, not just that we like record as like alive in an environment. That now there are telescopes or sorry, not telescopes, microscopes. There are microscopes that you can configure that are using digital image. So when you're using digital image, you're using a computer and you're using a GPU inside a machine. So this GPU can talk to another GPU and construct upon that GPU all the possible changes inside the nanocells. So it started reading patterns from our cells, body cells. It's like health now have became to a point that artificial intelligence has started developing antidotes and started developing some sort of avoiding possible scenarios that happens inside your blood moving inside your cycle, stuff like that, or certain mentions to avoid certain disease. So in the healthcare system, biotechnology is basically an understanding of the same computer models that have been used in clinics, hospitals, used everywhere, into larger machines that can consume this kind of data, make it process, give supervised learning, and then be able to make an output. So the finance now, like I'm going to use this, like the banks and the predictive GIS and the banks as well. You can see now how it's being conducted. And also in finance now, you can imagine that the computer now, or the more artificial intelligence exists, and the more it is in our daily life in companies, the more you put in the CRM system, the ERP system, the more you put sheets, slides, more customer data, more finance data, more transaction data, more booking data, more Excel sheets. It now has a larger and larger output of modules that will be able to put together some super equations from the all what's happening in the market, what's happening in the stocks, what's happening in companies. Now it understands all of it. So it's a mediator to understanding all the predictions and the patterns that are happening in the market right now. So it can take further decision and investments rather quietly. And now there are models that are being conducted for investment by models. That means that you can work with each and every model. So you can be able to see, for example, a job that is purely programming artificial intelligence, or you can see like a career where it has like a data science scientist, for example, that data science will be able to understand these kind of measures with the help and applications of AI, and will be able to build GIS models or build models that will take decisions that affects the company finances. So business analysts, data scientists inside companies, they have to start to get ready now for artificial intelligence, because now all the programs, all the major tech platforms that all the companies are using right now is already embedded from the mother technology company with artificial intelligence. So navigation and transportation now, you can measure, of course, you can understand now how it is. All the computers, when we put together, we have data set that says this road, Shady and X and Y is on this road. They're all in the car because they're moving at a certain speed from the satellite location. So basically, when X and when Y stops, doesn't take an action, when doesn't take action on the timing of like how you're going to reach the end of the road, or like in this minute's time from your travel time. And now the ability to build the heat map where we say like this is the daily thing that happens to us every day. When you see on Google Maps that there's like the red line, that means that this is jammed. How did it reach an exam? It's not a heat map. It's not an imagery from the satellite. No, it's like how many devices are there that are stopped. So why stop? It's fine. It wouldn't affect. Why did X stop? So this is going to start to look for Shady. It's going to look yellow. If Shady stopped, make your grid for each and everybody. So it's like how many stopped models in the neck can contain the traffic in the jam. And then it gives you the visual output on the other hand from the GPU. It gives you the visual output of how the road looks like right now. So content creation is definitely one of the things now that we can see that is evolving around social media, and how the social media platforms are starting using artificial intelligence in so many levels, on videos, on images. Let me tell you, I'll tell you a little bit thing about this. Now, remember when we were talking about the machine and the very basic example of giving it a boat in a lake, a picture of a boat in a lake? Remember when we were doing unsupervised learning and we told the computer that the imagery of this boat can be in different colors and different shapes and stuff like that, without having to make the input of the image? Imagine now how many imageries are inserted in AI models or the internet. So many data sets to visualize from. So you can manipulate the content. It's not just like asking how to like construct a visual of a boat that has 2 yellow strips in it. This is became basic now because it has seen all shapes of types and boats. So if you said, get a boat that has this name and has somehow an abstract technology background painting and have it black, for example, I will do that because I can see there's definitely been done there. That someone has 2 strips on the bottom, there's like how it looks, and then it can manipulate it and do it and put it all together into a mixture of what we see. So when you're actually asking the artificial intelligence to become creative into like asking Copilot to construct the image, it's not actually a brain that is functioning behind it. It's eventually so many GPUs, so many editories, so many imageries, and so many footages that put together somehow. And the graphic or the GPU starts to output it all together by drawing the pixels. So there's no brain behind it. It's also images and human interaction. So yeah, so these basically, so I'm trying to say is like basically anything that works on a computer right now should be able to have like an AI models on it. And there's like so many levels that can be affecting the businesses that we're living in right now in artificial intelligence. If you're very good at coding, very good at Python coding, you can develop your own scripts and you start from there. You can start having your own data lab by providing for different companies, different resistance scenarios and codings that put together an algorithm how to help them with AI. So you actually, if you do have the background on programming, it's an easier scenario to develop things that are being used for AI programs. If you don't have a good programming or advanced programming background, we can start by getting into data and understanding how the data is being read by the computer and how that can make a predictive analysis and such, and you became a data scientist or you become into the data science field. There is so many possible solutions now into the artificial intelligence needs a lot more of learning and availed more fields. Like right now, artificial intelligence jobs has become the #1 list in the past year. This means that the worldwide, most job that was required worldwide the past year was something has to do with artificial intelligence. or supplementary technologies. Supplementary technologies like technologies that products that are being built to help SaaS services or cloud services or something that has a user interaction in it, to take these kind of packets from these mutual cohorts, we can call it technology cohorts, into getting data management that can be used later on and processed later on with so many other companies as well. So it is hidden in the field. The AI is hidden in the field. Like, where is it exactly? What companies exactly? But if you hunt it down online, if you start looking into it, you definitely get into that. I feel like I have taken so much time. I think it's more than what we have anticipated, I believe. And yeah, so now I'm just gonna go over before we finish. It's like a QA session, so I'm gonna go help of Yasmin here. I'm into like conducting. If we have any questions and inquiries, please come forward. Whether if you think it's too simple, too complex, please do that. So yeah.
Thank you so much, Dr. Shady, for that informative and insightful presentation.
Thank you.
I think we have a couple of questions in the Q&A.
Sure.
Okay.
You
I
want
encourage
me to
everyone. I can help you with that, but first let me encourage everyone, like if you have any questions, feel free to type it in, and we'll address them as soon as we read them.
I can tell them right now. So
Yes.
Sammy, it's like, what kind of an AI is ChatGPT? ChatGPT is an unsupervised machine, unsupervised learning machine. So that means if you are like, I'm gonna go back to the slides here. I say the unsupervised learning is like when we talked about. It's like, I'm going to be doing this really, really quickly again. So you will have unsupervised learning, and you have the system learns from the training models and learning from the things that you will have to input. Now you make the machine unsupervised and learning internet data set or data that is coming on from elsewhere, which data companies or AI companies now that provides data sets, you can easily look up online, for example, to get into a data set. And this data set is a much of patterns of text or something that is very specific, something a topic-based kind of an intelligence on something for a data set. And when you take this data set, you put it in a Python program, and you program certain scripts and certain programming that says, learn from everything somehow, like metrics, everything, and use the patterns to be able to develop a possible outcome of this text. ChatGPT does it with the whole world. Corpus of data means the data that has been deleted from all of our machines, from the company machines around the globe. So everything that has been deleted, and had a consent, of course, but they had so many consents in place to have their machines take from the corpus of data. So if you remember when it was launched, it was specific to time update. It wasn't updated with the real life scenarios. So basically now it does. But it's an unsupervised machine. You get a machine, and inside a machine, you set up a Python environment, and you put a data set, and you get or pull a request from this data set, and this data set will be on your code base. And when it's on your code base, you start to insert Python in it. And when you put the Python, there is a library as well in Python, which is like the NLP. And the NLP is a model now. You can insert in everything. You cannot like develop it anymore. It's pretty mature. So you get an LP, you put it inside the code base, and you have a configuration of an LP, and you have a Python algorithm of your own, and you have it have an output. So basically, this is the unsupervised machine when you're developing a GPT model, then became ChatGPT. I hope that answered the questions. What does a brain get implemented? Okay, machine intelligence. Yeah, that's a question you see. Now we have data maps. So basically, this is the question. This is very, very interesting question, Basma, because I asked myself the same thing. Where does the brain organ get implemented on? In the spectrum of organized intelligence, you have basically the kind of a constructive brain map already. There's like brain maps that are available, bioscientific maps These labs provide all the brain activities that has been recorded and frequencies are like have been recorded somehow in any of the scanning machines that undergo any physical treatment, even MRI. MRI machine and the MRI machine itself, when it outputs like this black imagery of of a layer, it just shows one layer. There is a binary layer. There is a other GPU layers that is being embedded in these sensors as well. So this kind of data can give you an actual map of the lights, and then you will have to pay in the hospital or pay a clinic to be able to get it. But it is in the same, it's an MRI machine. So basically what you have is you have this packet, and then you put the brain map onto a virtual environment, and then from this map you start to have a very deeper point scale system that outputs somehow how this brain is being working, not the decision that it is. So neuropsychiatrist is somehow involved into putting the rules of algorithms from panels or research labs. So basically, I don't have it on my team now, but what we do, we get the data that's done already. So there's data that is done already on a brain activity that this brain has a tumor, so it's dysfunction on the level. So the frequencies and the levels that we can be able to get from this binary packets, we put it on programs or supercomputers, and these supercomputers can visualize data that's coming out from the other machine and shows a map of exactly how the brain is like mapped out. The kind of movement of an electricity on your nervous system, for example, when you're doing like the scans on your brain, the kind of like movement on the electricity, it is also shaded in other data set. So this data set can be mixed with the MRI scan and give us a possible outcome of how your neurons were or nervous system was working. And based on this, you get the trials and the labs that can test if I pinch this person, for example, if I pinch them, he will grow electricity in these kind of nerves inside the magnificent brain network. So this means it's pain. So now we have the map of brain, how the brain function, and we have nodes and a point scale system that reads whenever it moves to that direction, that means it's in pain or something that is alerted. So you build them upon that. So basically, now what we do is like the organized intelligence is a piece of like the cell in a constructed gel, and this gel has like all the support function that make this cell grow. And you start out with a very simple kind of a brain that it can do very basic things, like can react to something. You can put an input, you can put a voice, or put something, and you can react to it by drawing the map and how the map should be working. Because in each and every point you're going to construct in this map will be accompanied by a command that can be taken out of the computer. So whenever this bio movement inside this organ moves or electrifies in that way, you will be able to take this command. I hope that answered the question as well. I always believe it's not about technical tools that is developing so far, but it's about mentality. I use these technologies to invite different types of solution. Am I right? You're definitely right. And how to develop our intent. So I tell you, this is actually a perfect example of like how the institutions now, like being an AI expert, but I'm also like me, Shady, personally. So I develop a lot on with these institutions. There are some institutions and companies that are revolving now around keeping the sanity of human, meaning that if you are going to somehow show a baby or show a kid social media reels, and he's swiping across the reels, this is like his main directory now we're getting into information from. Our ages or our era understands somehow the develop, understand that there is something that is fake and something that is not fake. But now looking at the next generations, how they are going to make sure that what they are learning is legitimate, and if it's fake or not. So this basically messes up with the very extreme foundation of a human experience. And now, since the technology is becoming this super extended somehow, and we have a lot of things in place that is somehow able to read all of it, this is the field where it can keep mentality. So there's like an institutions that works behind filtering AI and making sure that it's legitimate, making sure that it's labeled as AI, making sure that with the user that is going to show it understands that this is an artificial intelligence. Like the tags of now, the Ometa, you can see done by AI. Done by AI, it is not as strong as possible, but this is one of the initiatives that these companies and institutions did as well, is to have a label that says done with AI, but now it relies on the AI of Meta itself. If you use a certain avatar or picture or something like that, it will give you this kind of an examination. But other than that, involvement or like all around the web and all around the internet, it is scary to keep the kind of like good and evil kind of side of technologies and on what you're developing. So it's basically the more algorithm scripters are being able to put some rules in place, patterns in place, scripts, programs to have witnessed somehow the kind of like a mental ability to maintain a human interaction with the computer. If you're talking about me personally, I'm definitely I lost excitement. Something like this is one like on but I've been like in this in 17, 20 years. But I've somehow lost the technology excitement. So whenever now there is a technology coming up, a product coming up, anything that is coming up, application that is coming up, I always know because I work in developing these things. So somehow you will start to lose excitement. For example, I game sometimes is like myself, but I've been working with Rockstar Games on developing NPCs for GTA 6. The whole world is talking about GTA VI, it's coming in and it's going to be blowing our mind. I already know what it is. So imagine the kind of like the kill of an excitement that can happen to you. Like you always feel distant from each and every news populars out there. But then there is a dark sense of confidence inside that. When you do that as well on a level, you will be able to comprehend like what you're doing is actually effective and it's affecting like worldwide scenarios. Um, just because you're working inside the technology and you're working inside developing these technologies that other users will be seeing as a surprise. I hope that answered the questions. Yeah, I think we don't have we don't have anything that's coming up anymore. It's good. We've taken an hour and a half. That's decent. So yeah, please let me know if you like want to like you can have my email if you like. I have an email for labs as well. You can take it from Yasmin, and if you want to take anything further, like a discussion or a topic or open essays, I would always be available to do that. So thank you very much for watching this today, and I hope that I have been in some sort of procurement to you.
Thank you so much, Dr. Shady, for sharing your valuable insights
Thank
today.
you.
Thank you so much.
Thank you. Appreciate it.
For
All
our
right.
beloved attendees, we hope everyone you found today's webinar useful and inspiring as well. Be sure to stay connected on our social media platforms and feel free to send me if you need any information regarding Dr. Shady. Please, before we wrap up, I'd like to remind everyone to stay tuned for the upcoming DSC MENA 2025. Which will be held next February. And it's going to be an exciting event filled with cutting-edge insights. So be sure to mark your calendars. Thank you again, Dr. Shady, and thanks everyone for joining. And have a great night ahead.
Thank you.
Thank you.
Bye.
Bye.